Hello, welcome to the workshop. My name is Daniel from Kaizen 3D Prints, and today we're going to be talking about 3D printing on fabric, part 2. I have been 3D printing for about 2.5 years, primarily focusing on 3D printing on textiles for about 2 years. I have 14 3D printers, mainly bamboo lab printers. I just got a Sovol SV08. I also have a Peoply Magneto X and a Creality K2 Plus right behind it. You can print on fabric with any 3D printer as long as your layer heights and speeds are adjusted. So today we're going to be going over the programs used to set up the models, slicer settings using Orca Slicer, printing the actual fabric, placing of magnets and removal of fabric, and then we're going to sew them up with a couple of different presser feet. So without further ado, let's check out some of the programs that we use. Okay, the first program that we are going to be talking about is Tinkercad. And if you are brand new to 3D printing or 3D design, I would check out Tinkercad first. It's free. It'll give you a good kind of introduction to it. So this is the main page. It's tinkercad.com. Create a 3D design. This will then open up a workspace, a work plane that we can navigate around. If we click down the mouse wheel, we can freely move around that. We can scroll in and scroll out with the mouse wheel. And if we right-click the mouse button, we can change our perspective. On the right-hand side, we have tools that we can start using. There are lots of different shapes, all of these different categories as well, and you can search. For this example, we're just going to create a text box in the middle, and we're going to change the text to Kaizen 3D prints. And we're going to show that we can resize by these boxes. We can either make it really squished or tall, whatever we want to make our parameters out to be. We're going to make it like that. And then up in this right-hand side, we're going to export everything in the design, or you can just select the shapes. And we're going to export it as an STL file. Now, before we get too far ahead of ourselves, I want to go over a couple of these terms so we're familiar with them. If you're familiar with these terms, you can just skip to the next part. The most common term that we'll find in 3D printing is an STL file, and that's a stereolithography or standard triangle language. This is what is generated from Tinkercad, for example, that can be imported directly into your slicer. A step file is one that takes it a step further. It's the standard for the exchange of product data. So if somebody else wanted to modify a file that I had worked on, I could send them the step file. If I were to send them the STL file, they would not be able to modify it. Moving on to a 3MF file. This is a 3D manufacturing format. So if I were to save, say, 10 STL files in my Orca Slicer, I could export it as a 3MF file. So I think of this as kind of the family of STL files with settings and parameters already added. Moving on, we're familiar with the JPEG. I didn't know this, that it stands for Joint Photographic Experts Group, mainly dealing with just compression. It makes files smaller. Then we have the two graphics, the SVG versus a PNG. SVG is a scalable vector graphic, which is vector-based, and the PNG, which is pixel-based. The SVGs are great for logos. PNGs are good for logos as well, but sometimes when you scale them up, then they become too pixelated. I prefer using SVG files. We then have the final file format that I use, which is DXF, and that's a drawing exchange format. That's what I use in my CAD program, Shaper 3D. That's all the information I have on these. Let's move on to the next part. Actually, Shaper 3D, the program I use the most. All right, the last video I just took on this deleted itself, so let's see if this one will work. Shaper 3D is a fabulous app. It's $45 a month or $300 a year. It's by far the most useful software that I use. So this is the little main screen. We're going to come up here and hit the plus button for the new project. And this is our workspace. It's the same technique. We're zooming in, zooming out with the mouse wheel. Come up here and hit the top button. This is how we can change the viewpoint. I'll hit that top button here, and a couple other things that will generally pop up. This is the history tab, so it has parametric modeling. So we can change something 10 steps ago, and it will change it for the present model if we don't like a thickness of something or line height, etc. And it will make all those changes in the future models. We'll close this. The next thing to note is this items tab. And when we create sketches or bodies, it will come up over here. So if we need to go back to something we've worked on, we'll look over this left-hand side. Go ahead and close that out. I'm going to do the same thing that I did with Tinkercad. So I'll come over here to this sketch button. And when I click that, a whole bunch of these other options will pop up. So we'll go to a text, and we'll do the same thing here with Kaizen 3D prints. You can change the size, and it will change it in real time. We'll stick with 8 millimeters. Arial text, great. Bold, you can change those. We'll hit continue. Now, before we hit this check mark, we can move this freely, and we can rotate it if we want to reorient it before we make it a sketch. We'll go ahead and hit that done button, and now we see all of these points pop up. If I hit either the escape button or this exit sketching button, I can left click on any of these faces, and you'll see that as I move the viewpoint, this arrow will pop up. And that means that I can extrude whatever height I want. So if I want these different heights, I can do that, no problem. We don't want to do that in this instance, but it's possible. Now, in this case, if I were to want to select all of them, we see this area selection pop up here. Left click and drag all items. If we hit the tab button, it goes through bodies, faces, and edges. So we want faces, and then we're going to shift click the spaces in between to remove those from what we're extruding. Now we can either left click and drag to make them all uniform height, or we'll change this to the 0.72 millimeters like we did the Tinkercad one. Now, before we extrude this, I want to show why I love Shaper 3D so much. So this is the regular text. And if we make a copy of this, we'll show two things. Over here in this items tab, we now have all of the bodies. I'll left click the sketch, and I'm going to make a copy of this sketch and drag it up. Now, in this sketch point, if we want to make a change, we'll see that the body, the D, will change as well in real time. That's one great perk of this. The other is to be able to manipulate these. Oops, I just hit the escape button before I hit solid. Oh, okay, there's the sketch. So if I drag these, for example, this gives me a much larger ability to manipulate all of these points before I export them as an STL file. So if I want the N a little bit jagged, and this is just going up and raising these up a little bit, then we can see, oh, let's see, oh, because I have this hidden. So we can turn this on or off, not because I hit the escape button. So we'll turn that off so we can see it. And now when we left click and drag, select the faces, and shift click and deselect these portions and make that 0.72, then we can have the STL file with the new text. So for this, we're going to left click, select just the bodies. I'm going to hit this isolate tab, the isolate button, and then show you up here in the export tab another reason why I love Shaper 3D. In lieu of just being able to export an STL file and an OBJ file, like a Tinkercad, this has a much wider array of different files that it can export to. So if I wanted to send this file to someone else, it can be a step format. I can make this a drawing or a sketch and export it as a PDF. There are lots of different things that Shaper 3D can do that other programs can't. So this is I love it. I can't sing its praises high enough. I gladly pay more for all it's capable of doing. So let's export this as an STL file, and we'll label this one the Kaizen 3D Prints V1. And then we're going to hit the isolate button again, and we're going to select just this one, isolate and export as an STL file. And we're going to make this one Kaizen 3D Prints V2. Fabulous. So we're doing the same thing here. We're going to come back to Shaper 3D a little bit later on in the video to show patterns, but for now we're just doing the text. So we're going to head back to actually open up a new program, Orca Slicer. Okay, this is Orca Slicer. We'll go back to the Home tab. You have your other projects that pop up. If you Google Orca Slicer GitHub, you'll be able to download the latest version for your operating system. I like this because I can opt between my different printers, and all the parameters are kind of universal. So with that said, we'll move from the Bamboo Lab a P1P, and we're going to switch to the larger one. We'll go to the K2 Plus. Actually, because this is multicolored, we'll stick with the P1P. If we go to the device tab, I can select the printers that I have with their colors that are loaded. So I think Charlie has the colored, rainbow colors here. And then we can hit the resync filament button, and those will change. So before I load in a file, let's change just a handful of things or show you this left-hand side. This is your settings. In the global tab is what we want selected, and we'll click this advanced tab. These are my current settings, but let's go ahead and just create a new profile so those that are starting from scratch can change the things that I'm changing here, and that should be sufficient to get you started. So going from 0.24 draft, because we print with the layer height of 0.24 on average. First layer height is 0.24, so we'll change that. And go check out part 1 if you want to learn a little bit more about the fabric thicknesses and the layer heights chosen for that. So if you're printing with a thinner fabric, then you can decrease your layer height. Because we're only printing 3 to 5 layers on average, we don't need a very fine layer height unless we're doing a hue forge print. So next thing in this quality tab we're going to change, I like changing this line width, the first layer, to 0.42, because I often do semi-detailed first layer prints. We'll scroll down here, and we're going to change from a classic wall generator, which does not vary the wall width, to Arachne wall generator, which will change. Here the description: the classic wall generator produces walls with constant extrusion. Arachne engine produces walls with variable extrusion width. So especially when we're doing more detailed prints, we want that Arachne wall generator chosen. I don't change anything else on this quality tab. We'll move on to the strength tab, scroll all the way up here. The bottom surface pattern, this is what I change most often to get different bottom layer patterns with tricolor and dual color filaments. My favorites are octagram spiral, Archimedean chords, Hilbert curve, and concentric. Here we want the top surface pattern to be a monotonic line for the cleanest finish. Then we'll scroll down here, the infill. I dislike grid very much. I either change it to gyroid or cubic, just a personal preference. Grid the nozzle will path over itself and often cause mayhem. So again, because we're printing with 3 to 5 layers, we seldom deal with any infill, and they're just solid layers anyway. Nothing else to change down here. Speed is the next largest factor. First layer speed, when I'm printing on my magnetic P-flat sheets and I want the best holographic surface, I change the first layer to 35 millimeters. Incidentally, this is the same speed that I print a majority of my TPUs, so I don't have to change the speed. The other layer's speed I also change to 35, unless I'm printing on an illusion mesh or petticoat tool, which then I'll bump it up to 50 to 75. But for safety, because I'm printing on average 500 to 1,000 pieces per plate, then I want slower speeds. If you are having still trouble with snagging, you can lower the travel speed, and you can just cut all of these in half. So if you're finding that your nozzle is moving too fast and it's snagging on the fabric, you can decrease these. You can also cut these in half, but not necessary. So we'll move on to the next one. Support, we have to make sure that there's no support enabled, because that would be printing into the mesh. And anything we change here? No, don't change anything else there. The Others tab, we make sure that there is no brim on it, because we don't want all the extra material being encased in the fabric or getting kind of mixed up there. So I don't have a brim on, and a majority of times, if I already passed it, my prime tower, multi-material, I disable the prime tower. If I want to print the full sheet, I'll increase the purge, which is here, the flushing volumes. We can change this. So this is the transition between, say, yellow to orange or green to blue, and how much is flushed through there. We can either decrease this if we want some sort of blend, or we can increase it, and those numbers will change. I find I don't get much effect with just keeping it the normal. I keep all of the purges anyway and reuse them. I don't throw them away. Now that those are all covered, again, main differences are the speeds that we have to change and the layer height. Let's load in the text from Tinkercad. We'll make 2 plates here. So this is the Add Plate button. And we will add the STL file. First one we have is from Tinkercad. Oh, nope, that's from Bamboo Lab. I must have misnamed them. We'll go V1. Oh, did I label over them? Let's see. V2, V3. Oh, okay. This is the Tinkercad, and I just labeled them incorrectly. So these 2 are the Bamboo. This is the Tinkercad. So I'm going to come up here, and if I wanted to manipulate this to be able to print it on fabric, what I would do is I would hit the scale button, and I would uncheck this uniform scale, and I'd change this Z height to 0.72 millimeters, because I generally print with 3 layers. First layer, pause, fabric and magnets, and then 2 layers to finish it off. So if I were to print this now, it wouldn't be shiny side down. So I'm going to left click, and we are going to lay on face, this button right here, which will lay it face down. I can do the same thing with these. The bed isn't selected. I'll left click the bed. These should already be at the 0.72 millimeters. We'll verify. You can also verify it right here down on the right hand side. Perfect. And then another way we can do that is if we select both of them using the control, then we can hit the rotate, and we can rotate these by 180 degrees instead of hitting the mirror button. Many ways to do things. Here we'll rotate this around another 90 degrees, and those are ready to print. If we wanted to print these all on the same, which I do, right click, select all, left click and drag, and then I can go ahead and shrink this one down. Again, the uniform scale is not selected because I don't want to change the Z height. I can then shrink that down. Oh, why did it change? Okay, we'll come up here and make that 0.72. And we'll go ahead and rotate this one so they're all the same direction. Great. Now, if I'm printing these all 3 at the same time, We'll give them a little bit of space so we can cut them apart. And if we hit the slice plate, it tells us it's going to take 5 minutes, 6 times to prepare. Over here on the right-hand side, we can see our total height of 0.72 millimeters. Left click and drag down to the second layer, and we'll right click and add a pause. So this will pause at the beginning of layer 2. So the first layer will print. We can zoom in and see that these aren't too small, that the level of detail still comes through. We still get those peaks in there. So we can go ahead and slice this plate one more time. Let's send it to the printer. Send it to Charlie, and we are going to print it in, let's do green. Okay, away it goes. Next thing we're going to do, we're going to find an SVG file and then import it in Orca Slicer as an STL, and rather export it as an STL, import it as an SVG. I'm going to show you that method. And then we're going to make a pattern with it in Shaper 3D. So on to the next step. Actually, we're going to step over here and show you the process of adding this fabric on. We'll get our camera snuck in here. The pause command has been activated. So we have our 3 prints there. And we then have our illusion mesh that I just had, but it's so invisible that I almost lost it. We have our illusion mesh here that we'll place over the text. The amount of magnets that you use depends on how much you're printing, the amount of tension you want to place. I'll usually do 2 at the top, lift it up so it's not snagging on anything, drop it back down, and then I can secure the 2 bottom portions. I'll get 2 more magnets, 1 for each side. Like so. Looks like that needs to be brought up just a little bit. Okay, that should be enough. And then we'll come back around and hit the print button. And I'll show you what happens in here. Here we see the print resumed after the second layer pause. Fabric has been added and the material is being extruded through the mesh, attaching itself onto the base of the first layer that was printed. It has finished printing, the plate has cooled, and we'll bring it over here and pull it off. This first one, I had an old wiper nozzle, so I replaced the nozzle to get a cleaner finish on it. And that holographic P-flat sheet transfers the effect onto it. We see our 3 different versions, one that we augmented in Shaper 3D, the first generic one, and the Tinkercad version. All right, we are back. We took just a small break here. Here we're going to cover the conversion of some files and a couple different programs we already talked about. This was an animal print pack that I found. I just Googled animal prints, SVG, and Etsy, there were files that you can purchase. This is 18 different animal prints. Some worked, some don't. Some of the files aren't drawn quite properly, but the majority of the time this is my process. So the ones that we're going to use are, we're going to do the tiger, these ones right here, we're going to focus on. And there are 4 different files that you often get when you download one of these packs. This Microsoft Edge, this is the SVG. And we're going to be translating this, we're going to be bringing this into Tinkercad. I'm going to call that just a TC. This PNG file we're not doing anything with, the EPS file we're not doing anything with, and this DXF file we're going to bring directly into the Shaper 3D. So from there, let's go ahead and open up each of these different programs and then bring those files in and show you what happens. We are back in Tinkercad. We are going to import a file. Tinkercad supports STL, OBJ, and SVG files. We're going to select that SVG file that we just mentioned, the Tiger version. And here we are going to import it. It's going to be centered on the artboard. We'll import. Generally, this takes anywhere from 5 seconds to a minute, depending on the complexity. So we'll take a pause and wait until it loads in. Great. Now that this has loaded in, we see this small piece that has formed in the distance for some reason. We want to get rid of that. So before we export it, we are going to drag a cube over there, and we'll make it a hole. You can also just drag a whole negative, the whole negative modifier here. So when we export this, then it's going to select all of this and remove this. We'll go ahead and do that now. This process may also take 5 seconds to a minute. Perfect. Now we have this STL that's ready to be used in Orca Slicer. Now we're going to jump back over to Shaper 3D and convert the DXF file. In Shaper 3D, on the left-hand side, we have our STL pattern that we have exported from Tinkercad. That's, if I can select it, that's this one here. And if we zoom in, we can see that it's one body where we can not click on any of these faces. We can scale these individually, change the size of those. But for this example, we're going to be using this DXF file that's on the right-hand side. And we can tell that it's a DXF file because if we click it, then again, we can change all of these points like we were able to do in that text. So with this, if we were to move it, it's going to take a long time because there are so many points in it. If you have a very complex pattern that you're trying to do, your computer needs to be somewhat on the newer side. If you're trying to use a computer that's 20 years old, it might take a long time or potentially crash. So with this, I'm going to fast forward until this stops thinking, and then we'll extrude this pattern. Brilliant. Okay, hit the escape button, and same thing as the text. If we start selecting and we hit the tab button to the faces, and then we can zoom in here and deselect all of these. Then we can change our view, and we can extrude 0.72. I've already done this, and this is a one I'll load here because it does take a bit of time to process. I'm trying to save a little bit of time for this video. So now we can look at the difference. Here we have an individual face and the sides. So if we want to augment this, well, depending on what part we're trying to augment, it has to be a valid point. So we can change these faces, we can chamfer, fillet them depending on the height. We have made these just 0.72. We move on to this next portion of the process. We're going to turn off the SVG and we're going to turn off the DXF file. And here we're going to turn these bodies that we've now created from the DXF file. We're going to go to the pattern button here. Once we select that, it's going to ask, well, do you want a linear pattern or a circular pattern? We want indeed a linear pattern. Then we'll choose the quantity and the spacing. So I'd like this to be 3 wide and 3 tall. This quantity is going to remain the same. And this is going to be the spacing. This is going to be the width from the left to the right, which I measured at 281.1598. Here we'll hit the enter button and it's going to think for a little bit of time. Great. We can zoom in here and see that the seams are lined up. That'll be important when we union the bodies. We'll also want to go up 3 So we're going to make this spacing the height, which was 281.1097. Here I realized that my spacing was off, that I should have been about 0.1 millimeter closer to each other, so the bodies actually intersected and were not just adjacent to each other. I'm going to come over here to the History tab, and we're going to expand this pattern. Here we can change, earlier we mentioned the parametric modeling. So we're going to change this distance to be a little bit smaller so they intersect with each other. So this is going to be 0.15. And then this one is going to be 0.1. Great. Okay, lengthy process done. Now we can take these bodies and export them as their own STL. So we'll have two versions, one that was an SVG converted to an STL from Tinkercad, and the second that is a DXF version created into a 3D body and patterned and then exported into an STL. All right, this is the last thing we need to create for this example in Shaper 3D. I've made just 4 rectangles, and we're going to extrude just these portions. So we're leaving this center portion out, and we're going to make this 10 millimeters. Oop. I'm going to make this 10 millimeters. And then we're going to extrude or export this as an STL file. And this is going to be our negative modifier. We're getting near the end. Hang in there. So on the left-hand side, on this first plate, we have the STL file from Tinkercad. And on the second plate, we have the smaller version that's patterned from Shaper 3D. So on here, if we zoom in, and we'll start with this Tinkercad version, just so you can see the difference here. If I right-click on this file, we're going to add a negative part, and we're going to load in that tote bag negative modifier that we just created. Tote bag negative modifier, and that's going to load in somewhere else. We're going to left-click and drag it over our box. And then we're going to resize this until there are grayed out portions that are covering the exterior of the print. And we'll also make sure that this is, since we resized it, it shrunk down. We'll make it really big just so you can see it well. Now here we can see the bottom portion is grayed out. This is grayed out. And these two blocks are grayed out. As long as they are underneath the build plate, when we go to slice the plate, everything that isn't being affected by the modifier will print. So here we're able to create our templates to print and have the seam allowance that will go around the entire border. So we'll use this next example here if we right click and we do the same thing, or we'll load in that negative part modifier. And this is to showcase the different sizing options. So now that we have the smaller tiger skin, if we add in the negative tote modifier, and again scale this down, make sure that it's thick enough. Now when we hit slice plate, we'll have a more delicate tiger skin version here versus the larger one. So that's the reason why I shrunk it down and created a pattern with it. So wait until this loads in. Because there are more parts, it's going to take a longer time. Then I want to show the difference between the classic and Arachne wall settings and why it's important when we're working with smaller detailed prints like this, just how important that wall generator is. So here we can see all of these lines that are filled in, these delicate lines. Oop, And also, our generator did not work. Must not have been below the build plate. So here we can see that it wasn't touching. So we'll come up here to the move, and we'll make sure that's intersecting our model. And before we do that, let's go over to the wall generator and change that from Arachne to Classic. And we'll see if we can spot a difference. It should take a little less time to slice the print because it doesn't have to create all those variables. But also I'm assuming that the level of detail here will not be picked up by the Classic wall generator. So we see the shadowed portions here that were not generated because this wall remained that 0.42. But at least the modifier went down below, and we can now see the difference between, let's load this one again, between this larger tiger skin portion and this smaller tiger skin portion. So now I'm going to send each of these to the printer. One will be the small side and one will be the larger side. And for the final portion of this video, we're going to sew it up. Okay, we are back. We've got our two pieces that are printed, and we've just applied some base fabric underneath that we're going to sew them onto. This example is an illusion mesh, so it has a two-way stretch, 19 GSM from DFW Fabric Mart, and this one is printed on a power mesh or poly mesh from Joann's Fabrics. Now that's out of business. I'm also getting it at dfwfabricmart.com. Here I've put a couple of pins in here. I'll print up a second version, second size, so I can sew them up together. But then I have two other bag examples that I'll show you how I sewed, just options. Here, the sewing machine that I'm using, just really basic. It's a Brother ST371HD. I've got some white thread loaded on there, poly thread. And I have an adjustable zipper foot on here that I really enjoy. So let me see if I can get you a better, I'll just get it on the back side here. So this will unscrew, and then you can move this to the left and right depending on where you want that pressure to be applied onto your fabric. So generally I'll keep it on the right hand side, maybe 10 millimeters away, or a little bit less than half of an inch to the right hand side. And I'm using a stretch needle. You can also use a ball jersey needle, no problem. So we'll get this like so. Get you a good viewpoint. Oh, see if I can drop down. Apologies for the camera. Okay, get that like that. And here I'm going to start just at the base, the bottom of the bag. And because I'm sewing this base liner onto each of them. So I'll keep that on the corner there, drop that presser foot down. I'll hold my string taut and I'll bring my needle down manually. Do one turn. That's just my personal preference. Again, I'm a novice sewer, so if there's other ways to do this, by all means do them. I'm using this triple stitch, so it's going to go back and forth, and show you what this looks like here. So I don't guide it much, I'll hold it onto this backside here, and when it gets to that needle, I'll pull that out. And I'll just follow along the base of this. Could be getting a little bit closer here if I was paying a little bit more attention and not looking at the camera here, so I'll just focus on actually sewing. Okay, get to that corner, lift my presser foot up, flip it around 90 degrees, drop it back down. Oh, yeah, a little issue on the back side. I'm going to resew over that last portion. Cut this here. And then take a peek and see what we've got. So this is all the way sewn now. We'll flip it over on the back side and take a peek. It looks like it had a little bit of a jam, so I'll kind of clean that up and resew over that. It's the rest of the lines here. So really easy to sew with. The other option, oh, let's see. You can do that same thing. It would be the same effect since we're kind of printing on some stretchy fabric. Let's bring this back up and back down. I want to show these two samples, and I think that's going to be kind of the end of the video. So this was one that I did on it's a metallic silver with, again, that magnetic P-flat sheet. So this example I sewed up in black so we could see the stitching. And after this example didn't have a lining, so I just did stitch all the way around and I cut off the excess fabric, which you can definitely do if you don't want a lining. This material is pretty tough. Just wouldn't necessarily put sharp things in it. So here we can see when we do sew that, then we just we connect, we put the right sides together, we pin them, and then sew along that edge and cut off the excess fabric. Here I made just a small little pouch that I planned on hemming, rolling this over. So here then we roll this right sides out after it's done sewing. And let's see, get this. Some of the patterns you have to be a little bit more careful, but usually pretty good. So then here you can sew up another little bag and have it just be an inserted something. So then you can change the color, the background of that mesh if you wanted to. Here I planned on rolling this over and just making another little hem, rolled hem like this. So I'll show you this one other example. This I did a French seam. So instead of sewing them right sides together, we first sewed them wrong sides together around the edge, this edge, and we folded it inside. It was my first French seam, so I'm still kind of new to it. But once we had that liner on, then we flipped it back inside out, did a side stitch, a zigzag stitch around the whole thing to bind it. You can use a serger. Less people have sergers. So this is using that same negative modifier, which is what I wanted to show off. We'll bring this corner piece back out. Perfect. So this is using that same negative part modifier that we made in Shaper 3D, but using a houndstooth pattern. So we still have those two squares for the handle, and I think that just as a bag itself is pretty phenomenal. Then this is the longer piece that we paired together. So we patterned something that was about 30 inches, and we used the same piece of fabric without any seams in it using the Core XY printer. So we can lay the material on there. Actually, that's not something we went over. So let's jump over here and I'll show that example. Let's say, for example, we had something printed on here that was waiting to receive the filament. If I already had this portion of filament printed on a longer piece of fabric, if I want to do a headband or a guitar strap or whatever, then we can just drape the fabric over this. I don't think I went over this earlier in the video. I apologize if I did, but again, practice makes perfect. So then we have a little bit of excess material here and excess material here. So once that print finishes, we would remove this, print a third and fourth set, and just conveyor belt this down. So you still have the magnets that you're connecting onto the top of the build plate, and that filament is able to then connect all of these pieces together. So what we're left with is, I think this is 32 inches, it might be 30 inches. So then we'll sew this onto a black liner and then sew this strap onto, we have two straps. We'll sew it onto the portions that we left exposed, so the houndstooth will then kind of line up with that. All right, video's coming up on a little over 45 minutes. I want to wrap this up, just showing off briefly my thangs.com profile. It's thangs.com/designer/Kaizen 3D prints. You can find the link in my bio. This is an example of something else you can print, other examples here. This is another pattern, floral pattern, some other print in place things that you can make, card boxes, buttons, a heart pattern, negative modifiers. You can click on this free button here actually, and I'd start here with the 5 patterns for fabric and the basic negative parts. So they both have PDF guides you can look at, step-by-step directions. And if you want to support me and this journey, then head over to my link tree, check it out, thangs.com. And I'm even wearing something shiny like this. So this is just a square grid version using that negative square modifier or that negative glove modifier. So as you can tell, I'm having fun with this. I could talk about this forever. If you have any comments, questions, things you want to see for part 3, please let me know. And happy printing, everybody. See you later.